more like a demo, okay, for or an orientation for A2 chemistry. So now one thing, you obviously remember know what the syllabus is like. So I'll just go through the entire syllabus. Remember that A levels is AS plus A2. Okay, just remember that. And you know that in AS you've got P1, P2, and P3. You didn't have a lot of people didn't have their P3s. But in A2, you've got a P4, which is almost 40% of the entire grade is based on this. So your grades in AS can fluctuate. Okay, but you've got one very big paper on which your overall grade depends a lot, and that is your P4. Okay, and then you've got a small P5 as well. So you've got a small P5 paper as well, and this year hopefully everyone is going to give a P5 paper. That's barely 10%, I guess, of the total. And this 10% is like an ATP. It's also relatively easy. P4 can the problem with AS was that you had your MCQs, which were kind of more difficult. P4 is more like a typical structured paper. It's very lengthy, but this one is your structured exam. Okay, it's similar to your P2. And the only, just think of it as a lengthier version of P2. It's 2 hours. And it's got 7 to 10 questions. Okay, so it's much longer as well. Okay, but the paper pattern is exactly like your P2 exam. So one thing about A2 chemistry is that it's an overlap of AS. It's not very distinct from your AS. A lot of things that you studied already in your AS, it's just a continuation of your AS chemistry. The reason I'm saying that is there's a lot of overlap. In chemistry, every topic is overlapping with every other topic. So what happens is that, I mean, if you're studying atomic structure, it's going to be linked with chemical bonding. It's going to be linked with chemical periodicity. It will also be linked with organic chemistry. So all topics in chemistry are linked. So chemistry you don't have distinct topics. Everything is linked with every other thing. So your A2 is completely linked with whatever you studied in AS. Your A2 is going to be, I mean, you can't study A2. So when you're giving your A2 exam, you're in a way also giving your AS exam, because everything is linked. If you're doing a question on A2 equilibria, then obviously it's linked with AS equilibria. It's also linked with moles in AS. So everything is linked up. It's not like physics. In physics, you've got distinct topics which don't have anything to do with each other. So if you're studying gravity has nothing to do with electricity. They're completely distinct topics. But in chemistry, everything is linked. So it would be easier to give a composite as well. Like if you're not satisfied with your AS exam, you can give a composite, because if you're giving your A2 exam, in a way, you're also preparing for your AS exam as well. So it's very easy to give a composite as well. Baki 40% focus on that. If you struggled with AS grade wise, you can improve in P4, because 40% of the weightage is from P4. So the topics are in a way very similar as well. But they're the same topics actually. So I'll just I'll open the syllabus once more. There's obviously some distinction between AS and A2. If I open the latest syllabus, ठीक है, कहाँ पे टॉपिक्स कहाँ पे लिखे हैं? जस्ट अ सेकंड, यहाँ शुरू में होंगे. अच्छा, these are your topics. I'll just copy them. Yep, that's it. So these ones you've got. So these are your topics. This is AS, and the other one is A2. So kind of everything is similar. Yeah, that's your AS level, and this one over here is your A2 level. ठीक है ये. And the first thing, atomic structure. You were done with atomic structure in your AS. You did all of it. You did SPDF, etc. Everything was done. Atoms, molecules, stoichiometry, etc., moles, etc., equations. You did all of that. But remember, that is still a part of A2. I mean, A-level chemistry would be incomplete if you don't know about moles. So anything that you've already completed in AS, that's still a part of A2. Chemical bonding, most of it was covered in. Most all of it was covered in AS, but it's still a part of your A2 क्योंकि वहां पे आपसे you'll get questions on intermolecular forces, you'll get questions on sigma and pi bonds. So remember, A2 is just an extension of AS. So everything that's covered in AS, it's still going to come in your exams. But remember, the focus would be these topics. If it's going to come, it's going to come in a sort of tangential manner. It's not going to be, the whole question would not be focusing on atomic structure. uh, so bits and pieces would come from AS, but most of the topics would be most of the entire question would basically be focusing on these topics, but there would be bits and pieces that would be coming from these topics over here. States of matter, ideal gases, PV0, NRT, that was also covered. Now energetics, most of it, energetics is kind of split. That's the part. That's the first topic that you study in A2. Okay, so I'm underlining both sides. So energetics is the first one. That's where you start. Okay, we're obviously not going to cover the old AS topics. So you did some energetics in AS, and you're going to do a bit more energetics in A2. Nothing really new. It's just going to be an extension. It's just going to be more applications of the same concepts that you've already studied in AS. So same concepts in as in AS. So it's just a minor extension of that. So not much there. Then you start off with electrochemistry. And now in AS, you really didn't do a lot of electrochemistry. In AS, what you instead did was redox. You did redox. Electrochemistry as a full complete topic would be covered in. It's going to be covered in A2. So you've not studied. So this would be completely new. It's going to be a new topic that has nothing or not much to do with AS. It's got something to do with redox reactions, but it's just going to be a completely new topic. Equilibria, you did KC and KP. Okay, so you did study equilibria in AS, and in A2 you're going to study further applications of that. So it's not going to be a new topic. Again, it's going to be the same concepts that you studied in AS. Except an extended version of that. So it would be like studying KC and KP again, but with further applications. There's going to be K, which is exactly the same as KC. There's going to be KSP. There's going to be KW. There's going to be lots of other constant, which are basically just extensions of KC and KP. And then reaction kinetics. Again, you really didn't do much in AS. In AS, the only thing that you probably did in reaction kinetics was So the only thing that you actually did there was, so can you guys hear me? Sorry, hello, आवाज आ रही है?
Yes, sir.
अच्छा, इसका मैं एक सेकंड इसको रब करें यहाँ से. अच्छा, so reaction kinetics. So reaction kinetics was you never really did that in AS. You just did Boltzmann distribution, and you just studied a bit about catalysts. So pretty much everything was left for A2. So this would be new as well. I mean, it would be like studying a new topic. So basically in physical chemistry, there's going to be two new topics that you will be studying in physical chemistry. Equilibria would be an extension. Energetics would be an extension. So in energetics and equilibria, you wouldn't be studying new concepts. It's just going to be new applications. That's it. But in electrochemistry and reaction kinetics, everything would be very, very different. अच्छा, फिर inorganic पे आ जाते हैं. If you talk about inorganic, there's not much of group 2 that's left. You've studied most of group 2 already covered in AS. So mostly covered in AS. Only a few minor points, that's it. So this one is mostly covered in AS already. This is the new topic, transition metals. That's not studied in AS. So that's going to be a new topic. And then we come to organic chemistry, which is kind of the same. It's there's hardly any difference except for they haven't written here. I mean, over here it's not written explicitly, but I'll tell you what the difference is. It's just going to be this is your AS chemistry. A2 organic chemistry would be revolving around. If I just write a summary, that's going to be revolving around benzene and its derivative compounds. So that's one thing, benzene and its derivatives. This chemistry, AS organic chemistry, was revolving around hydrocarbons and their derivatives. Like you had a carbon chain, you had an OH, you had a halogen in it, you had a C double bond O in it, made it a carbonyl group, you had a carboxylic acid. This one is about benzene. Benzene is this thing. Benzene is, you must have seen this structure, which is this one. So the structure of benzene is this one, the one that's on your screen. This is what a benzene looks like. So just like your straight carbon chain, which you studied in AS, which had all these OH groups and your carboxylic acid groups, different groups attached to it. Now you'll have a benzene, and that benzene will have different groups attached to it. You'll have benzene derivative compounds. You'll talk about benzene, just a second, derivative compounds. So it would be very similar. So it's going to be something like this. It's so you'll have a benzene. This is the ring. You'll talk about phenols. This is benzene with an OH. Arenes, that's a benzene with an alkyl chain. You'll have benzoic acid. That's a benzene with a carboxylic acid. That's a ketone, a benzenone, a benzene with a ketone group. So everything would be revolving around benzene. This is a phenylamine, benzene with an NH2. So just like your AS organic chemistry, most of the stuff would be revolving around benzene. So the structure, everything would be kind of difficult, kind of the same. This organic chemistry is smaller in length compared to this one, and it's kind of slightly easier. But again, this organic chemistry is linked with this organic chemistry. So in a way, you would kind of be doing both of them at the same time. Most of the questions would be focusing on this, but obviously some stuff would come from this as well. Then you have carboxylic acid and its derivatives. That's not studied in AS. You didn't really study carboxylic acids. Now you're going to study carboxylic acids. Nitrogen compounds, amides. You didn't study in AS. You're going to study those in in A2 as well. So carboxylic acid, nitrogen compounds. Polymerization is similar to your O levels polymerization, like your condensation polyesters, terylene, etc., polyamides, Kevlar, proteins, kind of very similar. And right at the end, there's an interesting topic, that's analytical techniques. That's similar to um, I mean, it has all those analytical techniques. Some of them you've already studied. You had analytical techniques in AS as well. For example, you did study infrared. You did study mass spectroscopy. So in A2, you're going to study some more of them. Okay, there's going to be a bit more of them. And so that's about it. So topic-wise, a lot smaller. Mainly two topics in physical, one topic in inorganic, and a continuation of organic chemistry. So topic-wise, it's less lengthier, very similar to what you've already studied. Uh, everything, I mean, mostly depends on this P4, which is 40, which has 40% weightage overall. So your entire grade is basically based on this. And the only problem that you're going to have is that in A2, you've got other things going on as well. So make sure you organize yourself very well, so that you don't have, because when you're giving your A2 exams, you'll also be applying to universities, you'll be applying for other entrance test exams as well, SATs and GREs. So make sure your schedule would be very full. So make sure you have sufficient time to do all of this. If this had 60% content, this has 40% content. So it's slightly easier compared to AS, but remember to give it enough time so that you have a good preparation at the end. So, any questions about this? Good questions, Nia? Shaya, Naseem, Amna, Alicia, any questions?
No, sir.
So, we're going to start with the first one.
So I have a question.
Yes.
What if a student get a bad grade in AS, but if if he get, or he or she gets C or D, uh, should he like
AS में?
yes?
नहीं,
Then
वही मैं,
if he get A in A2, so what will be the composite grade?
हाँ, उसके अंदर ये कि you can, what can happen is that if you get a C in AS, let's say ना, तो AS की जो weightage है, I'll just show you. I say it depends on what component you're getting the, or because of, where's the weightage? Just a second, paper one, this one. Okay, this is the overall weightage. Each second. That's 38.5. That's almost. I said this one is, paper one is 15%. Okay, so you might get a D in paper one, let's say. This one is approximately 40%. This one is 23%. Now, a lot of you didn't actually give your P3s. Okay, that's out of the question now. So you didn't give your P3s. But it depends if component wise, this one P4 gets a solid A, then obviously there's a very high chance of getting a B. क्योंकि in 40, हसीब मैं बताता हूँ एक से. So 40% of the paper has been done well. Okay, maybe you did well in P1, but you struggled with P2. So because of this component, your AS grade was lower. So वो AS grade के ना components होते, but if all three AS grades are bad, then I would go for a composite. If all three of them are bad, okay, then I would prefer to go for a composite, because पढ़ना तो आपने दोनों है ना, क्योंकि even for A2 you have
Then
A2.
on the result card, like if we get, when we get result, our component and our grade will be mentioned differently. Like P1 we get this mark, and
Yeah, after I
P2
think 1 month they send you the components as well. Yeah, after 15 days. Like initially it is not mentioned, but like 10-15 days after that, the components they arrive. Okay. So they'll tell you the components. और फिर उसकी basis के ऊपर you can make the decision, because remember for A2, if you're studying for A2, it's very easy to give the whole thing again, because if you're studying for A2, by default you're also studying for AS as well in a way. तो AS की तैयारी तो वैसी हो जानी है. मतलब if you're start doing all of this, chemical bonding is something that's very basic. Although chemical bonding is not a part of A2, but you'll have to study that again. That P3, I don't remember properly, but they said that P3 would depend on. It was supposed to be given based on P1 and P2. I mean, this is what they, if I remember properly, this is what they said, that if you're given your P1 and P2 and you get a certain rank, then they'll see a student with a similar rank and check what he's getting in his P3. So, for example, if there's a student who gets 30 out of 40 in his MCQs and he gets 35 out of 40 in his practicals, so they'll match you with that student. So that was how they were actually planning to do that. So obviously this P3 is dependent on P1 and P2, which is why the P3 weightage in a way would be bigger, or would be a combined weightage. It would be a combined weightage. Achha, chalo, but for chemistry, I'm saying that. As I remember, for physics and math, it's very hard to actually give the composite because the topics are different. Like in physics, what you study in AS, what you study in A2, they're very different topics. In chemistry, everything is overlapping, so it's a lot easier to actually give the composite as well. But make sure a B definitely doesn't deserve, even a C would probably not deserve a composite. I mean, if you even get a C, and based on the components, let's say you got a C, but you got a C this way, that you had a D over here and you had an A in these two. So that kind of C would be something that could easily turn into a B or even an A if you do P4 very well. P5 भी बीच में add कर दो. So P5, I'll just tell you what P5 is. P5 is like your ATP. It's like it's like they'll give you experimental data. You've never been to a lab, but you don't have to worry about P5. P5 is like some random experiment that you've never actually heard of. Like if I open a P5, just a second. I'll just give you a P5 example. P5 is paper 5, W20. Let's open this one. So here's a P5 example. I said in P5, you get 2 questions. There's going to be some random experiment that you've never actually heard of. This one you probably must have heard of, but so the first thing is it doesn't really have a typical syllabus. It's more about practicing different papers. For example, there's this experiment where you have a slightly soluble calcium hydroxide and it's known as lime water, and student measures the concentration of calcium hydroxide using the following method. So he's following a method that measures the concentration. So most of P5 is just common sense. I mean, he's doing something, he's following a few steps, and then there would be questions based on those steps. So there's a lot of common sense involved, and then a lot of basic experimental skills involved, but you would have to practice a lot. I mean, for example, suggest why the student leaves the solution for 24 hours in step 2. I don't know what this step 2 is. He's adding a spatula of calcium hydroxide to 250 cm distilled water in a conical flask, and he's topping it and shaking the flask thoroughly. Now, he said that it's slightly soluble. So if he leaves the flask, stop it for 24 hours, any calcium hydroxide that is not soluble will eventually settle down. So a lot of common sense. This is what he's talking about. I'm just giving you an idea. Calcium hydroxide isn't really chalk, but I'll give you an idea of chalk. So So something similar to this, he's allowing the insoluble particles that have not mixed to settle down. So, I mean, that's by common sense. That's what it says. So that's just a brief overview of what P5 looks like. A lot of common sense guesses. Okay? It's a lot of guesswork. So, and a bit of a moles as well. Then there's going to be a second question. In the second question, so I'll also break down this one. The first experiment would be kind of a design experiment. They'll design an experiment. It could be any experiment. For example, there's muddy water and you want to clean that water. So what do? You'll come up with some common sense guesswork. Like there's mud dissolved in water. So how would you separate the mud from the water, and how would you make sure that the water is 100% pure? So some random experiment. So the first experiment is all about finding errors in the experimental procedure and finding what mistakes have been made. A bit of estimation, like over here, he's asking you to calculate the number of moles of calcium hydroxide. So different specific questions about a lot about design. I mean, for example, predict and explain how this would affect. So if you make any changes, how would that affect the results? So things like that. Then you've got experiment number 2. There'll be 2 experiments. The second one is more about analysis. In this one, they'll do the whole experiment. The whole experiment would be done, and they would also give you the experimental data as well. And remember, this experiment, you've never actually heard about it. It's always going to be an experiment that you never heard about it. All you have to do in the second one is a lot easier. For example, they're asking you to complete the table. They just told you don't even have to understand what the question is about. They just told you, I mean, what comes over here? That's 1 over capital T, right? So this capital T is temperature. So it's 1 over temperature. So the first one is 1 over 333. Second one is 1 over 323. You just fill the table. That's it. Then they're asking you to make a graph, and they've told you exactly what that graph should be. Plot a graph of 2.303 log of 1 over t on the y-axis and 1 over t on the x-axis. So you had a table, 2.303 log of 1 over t, those values are plotted, 1 over t, those values are plotted. So just plot those values on the piece of graph paper. They told everything. They even labeled the axis for you. Everything is already labeled. So pretty straightforward. They'll ask you to, now they're asking you for 2 possible errors. So you would have to think about, where did the experiment go wrong? How did it go wrong? Write the coordinates of the points which you think are wrong. You have to measure the gradient of the line of best fit. So things like that. So the second question is also relatively simple. The first one is about design, how to design an experiment. The second one is about how to analyze the results of an experiment. So mainly 2 questions, but a lot of practice. It's just past paper practice. There's no specific syllabus. Just some brief ideas about what are the sources of error. For example, if there's a heating experiment, the first source of error is a heat loss that happens to the surrounding. So some of the errors are very obvious, but remember, a lot of common sense. TK Shan, is that clear? Bakiyon clear? I mean, we'll do this separately. This is just a brief, very quick overview of what P5 is all about. TK. But it's easy. It's relatively easy. All you have to do is just open a paper. I mean, some basic idea about experiments, that's it. Open the marking scheme with it and see if your guesses are matching the marking scheme guesses. Because remember, the experiment that they're going to give you has never ever appeared before in an exam. You won't even find this. I don't even know what this experiment is. For example, it's an experiment. What was the experiment about? It was the effect of temperature on the rate of the reaction can be investigated by the disappearing cross experiment as follows. So there was this experiment, and so it's always the experiment is going to be new. Chalo, let's start a bit on. Hopefully that's your overall general overview. एक P4 भी open करके I can show you a P4 as well. like what's the structure of a P4? The only problem is P4 is very lengthy. You don't really have issues with time as such, but really lengthy. I mean, 2 hours with 8 to 10 questions. Okay, so that requires some stamina. So just like your P2s, that's it. Okay, most of the questions would just be about P2s. So now about the difficulty level, this is just my opinion. Energetics, easy. Electrochemistry is kind of difficult because it's new. Equilibria is also difficult, and reaction kinetics is not that difficult. I mean, these two are difficult. Topic 24 and 25, electrochemistry, and in my opinion, they're difficult. Plus, they've got a lot of subtopics as well, so that makes it kind of harder as well. Reaction kinetics is fairly straightforward, although that's a new topic as well. You'll find it completely new, but you'll manage that. It's not going to be that difficult. Transition metals is easy in the sense that it's mostly memorization. It's just memorizing facts. So just like your, the closest match is chemical periodicity. It's like chemical periodicity. You just have to remember your facts. Organic is just slightly easier compared to your AS organic. And you're already familiar with the analytical techniques, so they're kind of similar. That's infrared and mass spectroscopy. So they're usually easy if you understand analytical techniques. So I'm going to start with a very first and basic topic. And that, also a question here. Is this all clear? आवाज आ रही है?
Yes, sir. There is no question.
अच्छा, चलो एक सेकेंड ये. अच्छा, just finding where's the. That's. Just 1 second. So I guess this is your TK 24 and it's starting at 23. So starting with the first one. And the first one we're going to study is, I'm actually not going to talk about energetics as such, but we'll start with entropy. That's something, it's a standalone topic, part of energetics, but kind of unique. Has got nothing really to do with energetics actually. It's a standalone topic. So we'll start with the first very basic topic. And that's entropy. It was a brief introduction. It's a very important concept. Has anyone heard of the word entropy before? Anyone, any idea? Hasib, कोई idea? Shayan? Per mole per Kelvin. It's some concepts are very powerful concepts and they apply to many things in many different ways, and their application. So no idea. So entropy is something, you must have heard about the word entropy because it's used very often in many different places. It's a very powerful concept in economics and physics. It's a powerful concept overall. And the same concept also applies to chemistry as well. So entropy literally means, the concept is very simple. It just means disorder. That's it. So when you use the word entropy, that's it's basically disorder. So when you say that something has high entropy, that means that something is disordered. And when I say something has low entropy, then obviously it means that it's ordered, or we can say it's less disordered. So, for example, you have your room, and your room is if you have a messy room, so you've got a messy, untidy room. Remember, the concept can be applied anywhere and it will still work. And on the other hand, you've got a clean, tidy room. So which one out of the two is a high entropy state? The left one or the right one?
Messy and untidy will be a high, and clean will be like a low.
Exactly. So this one is your high entropy state. That's your high entropy state, and that's your low entropy state. So hopefully just make sure whenever you hear the term entropy, you know what you're talking about. You're talking about disordered. If something is high entropy, think of it as being messy, as being disordered. If something is low entropy, then think of it as ordered. So now systems, every system on this planet, it moves between these two states. You've got a high entropy state, you've got a low entropy state. Same things, they actually exist in two different states. Just like your room, it can exist in a high entropy state, it could also exist in a low entropy state. Which of these states is easier to maintain? High entropy or low entropy? Think of your room. Is it easier to keep a messy room or is it easier to keep a tidy room? Which one of these states is difficult? Which one of these is unstable? And which one of them is easy to teach?
Messy is easy to reach, and make it tidy is hard.
So this one is difficult, right? And it's difficult to actually keep it tidy, right? So this is a very unstable state. A low entropy state is a highly unstable state. It's unstable and it's difficult to actually achieve it. So this one is our unstable state. And this one can be thought of as a high energy state as well. Because it takes a lot of effort to actually reach this state. I mean, if you want to make your room tidy, you would have to like do a lot of work. A lot of input has to go in. A lot of energy would be gained by the system. So this one is a high energy state. So when you see a neat and tidy room, the first thing that comes to mind is somebody has spent a lot of energy making it neat and tidy. So that's a high energy state. It requires a lot of maintenance, a lot of energy needed, but it's very unstable. I mean, it's going to remain tidy for a very small amount of time, and it would eventually, within 1 hour or 2 hours, it's going to become messy and untidy. So that is a very stable state. And that's a low energy state. Because to make the room messy or untidy, you don't have to actually spend a lot of energy on that. Uh, Most of the time, it just becomes untidy on its own. So you don't really have to do much. So if somebody is going to ask you that your room is very untidy, tell them that that's a very stable state. That's very low energy state. And this one is a very unstable state. I said now, so naturally, and I'm going to talk about the direction of these two arrows. This one is easy, and this one is extremely difficult. ठीक है? Is this concept clear? Is this clear up till this point? Yes or no? I said, remember, you can apply this concept. I mean, this concept entropy has certain properties which I've already described you. You've got unstable states, you've got high energy states, which are low entropy states, and you've got stable states, which are low energy states, and they're high entropy states. You can apply this concept to economics as well. In economics, let's say you talk about cash, you talk about currency, right? Or you talk about money or wealth. Wealth will get distributed in the most untidy way possible. Like if you give one person, let's say $10 million, eventually he's going to buy a car, he's going to spend that money, and the money would eventually get distributed among different sellers. Those sellers would then buy something else with that. And what will happen to the wealth? It will get distributed in the most random and most haphazard manner possible. I mean, this is not going to happen. Like if you give one person $10 million, and it's not going to happen that after like 5 years, there are like 50 people, and all those 50 people have, let's say, $300 each. That's not going to happen. So things, they tend to get messy over time. They tend to go towards more untidy or high entropy states over time. They don't like to, and the same happens to your car as well. The same concept can be applied to physics. Like, what will happen to your car when you buy a car? The car is in a very neat and tidy state. Every part in the car is working properly. What happens eventually? Over time, let's say after 5 years, you start using the car, things, they start to break down on their own. You're not doing anything special. It's going to break down anyways. So because it's very easy to do that. And the car would become more and more random and haphazard and messy and untidy. It's going to reach a high entropy state. It's very hard to go in the reverse direction. Very difficult. If you've got a 5-year-old used car, it's very hard to actually reverse this arrow. That's extremely hard. So can anyone explain to me with the room example, why is the high entropy state more stable or more probable? I mean, why is it more probable? Why is it easier to attain? Why does the car break down over time? Why doesn't the reverse happen? Why doesn't it become good over time? Or let's keep it to the room example. Why is your room always moving towards an untidy state? Why is it not? I mean, why don't you just leave your room for 10 days, don't do anything, and then all of a sudden it becomes tidy and neat and clean? Is there a mathematical reasoning for that? Last thing. I'll just explain very quickly. It's to do with probability. I'll just explain quickly. If you have a car, how many ways can you break down a car? There are literally millions of different ways in which you could break it down or make it untidy or messy, right? Is that clear?
Yes.
Okay, so there are infinite. Same applies to your room as well. The number of events are infinite. There are infinite possible ways in which you could make your room untidy. Okay, so there are infinite possible events. Same goes with your car. Many ways to break down the car. But how many different ways are there to make the car work properly? There's only one, right? So there's only one way in which the car is going to work properly. So just a few possible events. That's it. So there's just a few possible events. So let's assume that you have 1,000 events, Out of that, 999 events would be the ones that would lead to a messy state. There's just going to be one event in which you can put the things in the right order, and that would lead to a tidy room. So the number of probable events is just like a coin toss. If you do a coin toss, what's the weightage of getting heads or tails? That's 50-50%. But over here, the problem is the probability of getting an untidy, messy state is a lot more. There are a lot many events that would lead to a messy state, and there are very few events that would lead to a tidy state or a low entropy state. So things would generally go towards high entropy. They won't go towards low entropy. Think of marble. I mean, I'll just give you one more example. So this one, for example, this would be a good example. So if I have this one, there's only one event in which I can arrange the marble pieces in this way. No matter how much I shake, the number of possible ways in which I can make it messy, that there are too many events. So whenever I shake it, I'll always get something that's messy. It's if you keep on shaking the marbles, I mean, this is another example. If you keep on shaking these marbles, things will eventually move towards more and more high entropy states because they're more probable, they're more likely to happen. The low entropy state is very unlikely to happen. It's got a very low event. So I'll just sum this up quickly. Okay, what has entropy got to do with chemistry? So it has to do with what will happen. It's all about probability. What is going to happen? So remember, high entropy states, they happen. Low entropy states, they don't happen. If things go towards messy or untidy states, that's more likely to happen. So it's all about chemical reactions as well. You can apply this to chemical reactions as well. Chemical reactions that tend to go towards high entropy states, that would create more disorder. Like, for example, there's an explosive reaction which leads to an explosion. That's more likely to happen. That's a high entropy state. Meanwhile, reactions that tend to go towards low entropy, that they're more difficult to happen. So is the idea clear, this one? और यहाँ पे मैंने ना सारी प्रॉपर्टीज बता दी हैं उसकी एंट्रोपी की कि everything, the whole universe likes high entropy. That is more stable. ठीक है. It's the low energy state. It's easier to attain, and it's the more probable state. ये वाली जो state है, that's more difficult to happen. So you can apply this to chemical reactions as well. And next class we'll also discuss how entropy is extremely important because a lot of things on this planet, especially mechanical work, happens due to entropy, due to disorder. So we'll talk on that as well. अच्छा, लेकिन इस पे कोई question नहीं है? Is this all clear? Asif, Shahan, Lisha, Amna, is this clear?
Yes, sir.
So it's a very small topic. We'll probably be over with this topic in the next class. तो फिर next Monday को फिर discuss करते हैं, ठीक है? चलिए, okay, take care. हाफिज.